Number 7 is asking you for some definitions here. There are other things you should be able to define, and I know I didn't go over these explicitly in class. We do cover them in Enviro, and they're somewhat relevant here, but not assessed very often. An open system is one that exchanges matter and energy with the surroundings. So if you want to imagine it as a pot with the lid off, if I'm boiling the water, vapor can leave, heat can leave, etc. A closed system exchanges energy only and not matter. So now think of it as a pot with a lid on. An isolated system, however, exchanges neither. First of all, isolated systems are purely theoretical. There's no way to perfectly insulate something. However, there's a lot of assumptions that we make when we're doing experiments that we are only exchanging energy from here to here and it's not going somewhere else. So we frequently assume that something is an isolated system for a short period of time. Like if I drop a hot metal into cold water, I'm assuming that all of the energy that leaves the hot metal is going to go to the cold water and nowhere else in the world. And that's not realistic, but it sure makes the math a heck of a lot easier. Okay. Heat of hydration should be in your notes. And it should be in your notes as the energy released actually, it's probably more correct to say the energy change, though it's going to be a negative value. When 1 mole of gaseous ions become aqueous. So as a new bond is forming between water molecules and gaseous ions, and then they become aqueous ions. So this is a bond forming. So that means it's always going to be exothermic. Something else that we talked about is we did talk about lattice energy. And that most definitely is in your notes and something you should be able to define as well. Out of these possibilities, I'm going to ask for 2 of the 5. Where this was heat of hydration, lattice energy is the energy required to basically break a mole of ionic bonds. To take 1 mole of an ionic compound, that says required, abbreviated. And convert it to gaseous ions.